Welcome to qnawire.
Hello, so today it looks like we're looking at potassium, which is K on the periodic table, and it has a number of 19. And we want to look at its electron shell today. So I'm going to start out by just drawing out a notation of the shells, starting with 1s. So the first shell only has this s orbital, so that's the entire first shell right here, 1s. And we know that an s orbital can contain 2 electrons. So we have 2 electrons in this first shell. For our second shell, we also have an s orbital, which also contains 2 electrons, but we can also have a p orbital. So we have our p here. And the p orbital can hold 6 electrons total. So on our third shell, we're also going to start out again with the s, which holds 2. We have a p, which holds 6. But once we get into the third orbital, we also have the third shell, we also have a d orbital. And the d orbital can hold 10 electrons. And as we get into each concurrent shell, it continues this pattern that you can see kind of like a pyramid. So the larger the number of the shell, the more orbitals it will have, and the more complex it will get, and the more electrons that it can hold. And so today we won't be looking at the fourth shell, but that is important to note for when you get into your higher number on the periodic table. So for K, we have 19. So to figure out what its shell is going to look like, we need to count how many electrons can fit in each shell. So we know for our first one, we have only 2 electrons total. So for our second, we know we have 2 in S, and then we can have 6 in P, so that's 8 total it can hold. And for our third, we know we have 2 for S, 6 for P, so 8, and then D can hold 10, so that's 18 total that it can hold. And we are looking to hold 19 electrons. So we're going to start filling from S. And a good way to visualize this is through these diagonal arrows you'll see sometimes, and just shows you the order of filling. So that's how you can tell where the electrons will end up on the period, or end up, and how you can determine how many shells are going to be filled. So it'll start from the 1s. So we have, to have a total of 19, we have 2 completed. Then we'll go to 2s, so that's 4 completed. Then to 2p, so we'll add 6, so now we have 10 total electrons at this point. So this 2 plus this 8, so we have 10. And so our first and second orbital are filled, but we have 9 left over still for our potassium. So where is this 9th electron going to be? And that's going to tell you, that's probably the most important position to look at, because that will give you the answer for this question, also tell you precisely where it's ending, which will differentiate it from other elements on the table. So we have fill up this 3s, so we have 2. So now we're going to have 12 total. We fill up the P, that's another 6, so now we're at 18. So once we get to 3p, we are at 18 electrons, and we know we need 19 total. So we're going to add 1 more electron, so we know we'll have 9 electrons in this shell. So we have first and second shell completed at 10. So both completed, stop. And then we have our 9 extra held in the third shell. So a way to write this out also, we can do 1s is full. So 1s2, 2s2, 2p6, 3s2, 3p6. And so we know these are all full. Also, these little numbers are an easy way to count up how many electrons we have so far. So we have 2, 4, 10, 12, 18. We need 1 more, so we have 3d. And we only have 1, so we have 1. So once again, we have first and second shell completed, and then an incomplete third shell with 9 electrons. All right, I hope this helped.